Question, we are given that the absolute value of x square minus 6x plus 5 is 0 and the absolute value of z plus 3 is equal to z square plus 2z minus 3. And what is the minimum value of the product of x z, as in the possible values of x and all possible values of z product? First off, we have to definitely find the values of x and the values of z which are satisfying. So let's start with the x. We have the absolute value as 0. This definitely means that the inside term should also be 0. Then only the absolute value will turn out to be 0. It means that we have absolute value of x square minus 6x plus 5. If that is 0, this will imply that x square minus 6x plus 5 is also 0. And this can be easily factorized, because if we rewrite negative 6x as negative 5x minus x, then from the first two terms, we can definitely take out x as a common factor. So if we do that, we have x is taken out, we are left with x minus 5, and minus 1 is taken out, we are left with x minus 5 again, and this is 0. So if x minus 5 is taken as a common factor, we are left with x minus 1. 5 times x minus 1 is equal to 0, which means that the possible values of x are 1 and 5. Let's keep it aside. Let's talk about the other one. So we have z plus 3 absolute value. Let's take a different color over here. Z plus 3 in absolute value is equal to z square plus 2z minus 3. Right, so there will be two conditions since we need to open up this absolute value. So the condition 1 is going to be when z plus 3 is greater than or equal to 0. So if that is the case, then z plus 3 is just going to open up, absolute value z plus 3 is going to open up just like that with a positive sign, because that is already positive. So z plus 3 is z square plus 2z minus 3. And if we rearrange this, bringing all these terms over to the right, so we have z square plus z minus 6 is equal to 0. And this can be easily factorized now, because this becomes z square plus 3z minus 2z minus 6 is equal to 0. This would mean that from the first two, we'll take z out. So we are left with z plus 3. And then we are taking negative 2 out. We are left with z plus 3 again, and that is equal to 0. Now, if z plus 3 is taken out as a common factor, we are left with z minus 2. And from here, the value of z comes out as negative 3 and z is equal to 2. But make sure that these values add up with this particular condition, because that is the condition which we need to fulfill, because that's how we'll get from here. So if this defeats this, then we cannot really come over here, and we need to ignore those conditions. So if z is negative 3, then negative 3 plus 3 is 0, which is allowed. So z equal to negative 3 is allowed. And if z is 2, then definitely 2 plus 3 is 5, which is also allowed, because that is positive number. Now, let's talk about the other condition when z is negative. Sorry, z plus 3 is negative, which means that now z plus 3 will be, absolute value will be opened up with a negative sign. So that's negative of z plus 3 is equal to z square plus 2z minus 3. If that is the case, then let's open the parentheses, that negative z minus 3 is equal to z square plus 2z minus 3. So this minus 3 and minus 3 is cancelled, and we have z square plus 2z plus z. We have z square plus 2z, and this bring over to the right, so that is plus z, and that is equal to 0. This means that z square plus 3z is 0, which means that if we take z as a common factor, we have z times z plus 3 is 0, which means the two values of z are 0 and negative 3. So let's see, if 0 allowed? No, 0 is not really allowed, because if we place z is equal to 0, if z is 0, then 0 plus 3 is 3. And is 3 less than 0? Not really. So we have to ignore this. And if z is negative 3, then negative 3 plus 3 is 0, and 0 is not really allowed. So both the solutions are rejected over here. All right, so what are the possible values of x and z? This is coming right away on the screen. So that x possible values are 1, 5, and z is negative 3 and 2. So what are the possible numbers which we get from the multiplication of these numbers? So let me do it over here. So x values are 1 and 5 allowed, and z values are negative 3 and 2 allowed. So there can be four possible numbers. If x is 1, and z is minus 3, then the product of xz, let me make a table over here, because that would be more clear. So let's say this is the table, and here we have x, here we have z, and here we have the product of x, z. Now, if x is 1 and z is -3, the product is -3. If x is 1, z is 2, then the product is 2. If x is now 5, z is -3, the product is -15. And if x is still 5, z is 2, then the product is 10. They're asking the minimum, so it's pretty much intuitive. The minimum is -15, and had they have asked the maximum, then the maximum is 10 over here, because clearly the 10 is the maximum among all these values. So, but as of now, they're asking for a minimum, so the minimum value is -15. So we are going to mark option D as the correct choice. Thank you.